Hello, my name is Carlos Agreja, and this is a C++ program. It is the nQueen's puzzle. So I'm going to insert a 4 here, and I get this output of two solutions. Okay, so these 4 values for the solution are the columns within each row. So basically this is an array, and each index, so it's 4 by 4, so it's really an array of 4, and for each index, which is each row, we have the column, we store the column. So, and that is also going to be for 4 by 4, 0 through 3, because it starts from 0. So the rows, which is the index of the array, will start from 0 through 3, and these as well as the columns also 0 through 3. So yeah, that's pretty much all I have to show there. I'm going to go over the code, which can be a little confusing, so hopefully I can help and not make it more confusing. But anyways, here it is. So just call this main project. It took a number that I inserted, and then it's created the queen puzzle, passed in the 4, and then we have this configuration which passes in a 0. So, and then it outputs the solutions. So start off with the initialization, which would be here. We passed in a number, so this sets the number of queens, and it also sets the array and the size of the array. So we initialize the array here, and that's the size of the array. So like I said, this is kind of interchangeable. The number of queens and rows are kind of interchangeable, and the values are the columns. So, and I changed some of these variables because they were I, J, and K, which is, and I obviously wrote a lot of comments here because it can be easy to get confused. So yeah, so hopefully this will help figuring this out. So the queen configuration, that was called next, and basically just passed in a 0. So the queen is also going to be from 0 through 3, which will be the 4. So what this says here is we want to find a column for each queen. So as we already saw, we have the array list. We want to fill that with the columns for each queen, and we got to find what columns work and don't interfere with other queens on and what columns will work without interfering. So what column can we place the queen on each row, a queen on each row, and they won't interfere with each other or from attacking. So that's how that's what this program is designed to do. So we have so we want to find those columns. So we have an int column, column less than number of queens, column increases, place queen. So we do this check here. Can we place the queen? We're going to pass queen, we're going to pass column. So we're going to do this check here. So I wrote some information here. So row can be interchangeable with queen because 1 queen per row, so it's going to be the same number of queens as the same number of rows. Also, this tests to make sure that there is no other queen on the same row, column, or diagonal, or it will return a false. So in this case, we're passing a 0 for the queen and a 0 for the column, the very first iteration, and yeah, basically the very first recursion. So row equals 0, that's going to be less than is this is not going to be true, this boolean. So it's just going to go right to true for that. However, I will discuss this code anyways. So what this does is, let's say we pass in something else, like I said, queen, same number of rows, so queen can go here, and row, we're gonna just basically go through each row. So as I said, over here, this rows points to a value, which is the column, so you can see this is correct here. That looks like it's okay. And then this absolute, what this does here is, if this value equals this column, so this is another row, and if it has the same column, then, and it equals the column that we're passing in, then that's not going to work, because they're going to interfere. You can't be on the same row, column, or diagonal, so that's not going to work. And then we check to see if this is true. This basically returns a column value for that row, and minus this column that we're passing in. If that equals the row minus queen, and obviously these are absolute values because we don't want them to be negative. But if this equals, if they equal each other, that means that they're on a diagonal. So that's what this is for. So that's that check, and basically that's how that works. It will return a false, otherwise returns true. So we'll go back over here, and so can we place queen? We just saw that code. So now inside here, set the column for that queen to that row. So can we place the queen? Obviously it's returned true, so we're going to set the column for that that row for that queen. So you can see that, and like I said, row and queen can pretty much work interchangeably in this case. Last queen has been set, print the solution. So basically that's what this does here. Once all queens have been alright, obviously this time it's not going to be the last, it hasn't gone through all 4 queens, so let's say it's not the last queen, and we go here, so we pass in, what was it, to queen 0, so we pass in queen 1 now, and it will call this method again. That's recursion. So, and basically this is when we finally find the solution, then it will print configuration. But again, this is recursion, so this is still going to execute, so it's still going to check, even though we say found, yes, we can do that, and then go here, it's still going to keep going and checking the other one. So it'll basically backtrack, it'll still check every single possibility, and that's how the two solutions were found. So this should check for every solution. So that's how, yeah, that's how that works. And yeah, that's pretty much it. Hopefully this was helpful, and thanks for watching. Goodbye.